Here's a quick review of Chapter 14 before you take the quiz, or just to review the highlights. This is on sports nutrition. There's a lot of material that's pretty obvious in this chapter, but just remember that with physical activity, it's not just the aerobic effect and the improvement of your heart. There's many other parts of your body that are improved, like for instance, bones and joints are strengthened. The bone density is actually increased from the tension of muscle contraction. Blood pressure is reduced. Even if you don't lose weight, just exercising can reduce blood pressure. Of course, it's strength, we know about that. Increases peristalsis, so with constipation, it's a great way to prevent constipation. Improves sleep. People have trouble with sleeping. Activity during the day can help. Improves cognitive function, just getting more oxygen content in our brains gives us much higher ability to concentrate and to work. Improves our immune function, so it actually improves the ability to fight off illnesses, and it helps improve stress. So there's lots of other importance points behind physical activity. And so we're just going to point out a few things. Then one of the things is just comparing exercise with physical activity. So exercise is when we plan our activities and you do certain things a certain number of times. Physical activity is certainly good, but we would not call something exercise unless it's something we planned into our schedule. So one of the easy ways to remember how to get the right amount of exercise is to use this physical activity guideline, which was set up in 2008. So this is what the goal is. Even though only 20% of Americans actually meet this goal, the recommendation is 150 minutes of some moderate activity each week. You can do a combination of vigorous and moderate, or you can just do it in 10-minute episodes. It doesn't have to be all at once, but just getting this total number of minutes during the week, and then breaking it down, or if you want to do it more extensively, this would be a higher level of activity for those that are more ambitious. And then to know how hard you are actually working, we can measure it by our rated perceived exertion. So there's two ways you could measure it. You could measure it by your heart rate, or you could measure it by how you perceive it, kind of like a survey of your own activity level, like how hard are you working. So they like you to see you getting a moderate activity would be a 5 to 6, or vigorous would be a 7 to 8 RPE. If we aren't sure what that is, the scale is this. So if you have difficulty talking, so for instance, the very strong end, you would not be able to talk while you're exercising because you're breathing so hard. But being in this area, you probably can still talk, but you're relatively energetically working, and so you're using your heart muscle. So the goal is to try to increase those who actually get to these levels of activity. So you would probably try to be in this moderate 4 to 5 level, or you can look at your maximum heart rate. And to do that, you just measure how many beats per minute your heart is beating, and then you would divide that by subtract your age from the number of you take your age minus 220, and then that's your max 220, and then you decide if you're going to be a maximal effort or a weight management effort, a heart zone effort. So for instance, if you were 20 years old, you would subtract 20 from 220 and you get 200. Now, if you want maximal effort from your heart rate, you would take 100%. You would want your heart rate to get to 200 beats per minute, or close to maybe 190. That would be your maximal effort. That anaerobic zone just means you are working so hard that you're not going to be able to get enough oxygen to supply the need. So in these two areas, it's actually anaerobic zone, meaning you have to produce some energy anaerobically without oxygen because your demand is so high. The aerobic zone, the 70 to 80%, so if you're getting 80% of your 200 beats, then that's probably you get sufficient oxygen to supply the energy you need to do the exercise you're doing. But just for weight management, you only need 60 to 70% of your maximal heart rate, of your 60% of your 200 heart rate, to help with managing your weight. And if you just want to improve your heart health, you only need 50%. So even just getting your heart rate to 100 or 110 where it's normally an average around 72 beats per minute, is still a good goal for heart health. So these all will vary depending how hard you want to work. The other way, like I said, is just trying to guess like how hard you're working by how much you can talk, kind of the talk test during your exercise. So these are the goals. We're trying to improve America and their activity rate. Now, where is this energy coming from? It's coming from ATP. So we talked about this in chapter 4. The glucose is the main supply of energy, but we can also get ATP production from fat and protein. So ATP, just by itself, anaerobically, only gives you enough energy for a couple seconds of work, but you keep replenishing the ATP so that you continue to get a few more seconds of work. So here we have the adenosine triphosphate. This is what's used to produce the energy for our muscle contractions during exercise. But with the ADP-ATP connection, we can actually replenish the ATP. So when we lose a phosphate, which is then used to produce more ATP, then our body from energy replaces that with another phosphate, so we can keep replenishing the ATP as it breaks down. Another way we can replenish it is with phosphocreatine. So this, sometimes you hear of athletes taking creatine as a supplement. So that's because the idea is that you can phosphocreatine has a phosphate group which can be donated to an ADP, which only has 2 phosphates, and it can be replaced to a triphosphate with 3 phosphates, giving it the energy potential to then release the phosphate again for energy. So this is what's anaerobically occurring in the cytoplasm if you are running out of oxygen. So if you're at that maximal heart rate where you can't produce enough ATP from the oxygen that you're breathing, you can get a little extra this way. So this is, again, the phosphocreatine can give energy because it donates the phosphate to the ADP, which can create ATP, and then you still have another source of energy. It's not a lot of energy. It's just this is like 10 seconds more. So this would be for intense activity like lifting weights. And of course, all this is going on in your muscle. You're getting this production. So this is the aerobic end here. So as you're breathing, you can produce some energy anaerobically, some aerobically to get the maximal amount of energy for your activity. And then here we have, just again, the anaerobic is limited oxygen. Only 5% of your energy really comes anaerobically, and that produces the 2 ATP, the lactic acid, which then can be converted by the liver to more glucose. Or if you have the oxygen, that's enough energy for up to 2 minutes of work, but of course it's replenishing the whole time. So the source of the ATP is the nutrients from our food. You can take these supplements, but generally the main source is going to be glucose or glycogen stores that we have from our diet. So here's the carbs. The carbs give the glycogen so that we have a little bit of phosphate to donate to the ATP, and then all the carbs, fats, and proteins are used for the aerobic, which overall can give you enough energy for hours of work, as long as you don't deplete these sources of energy. If you do deplete the fat and the glycogen, you still have amino acids in your bloodstream, which can be converted in your cell to produce more ATP. So it can go into that Krebs cycle or citric acid cycle and produce more ATP. So you have lots of sources: fat, glucose, and amino acids. And then what does your body tend to use the most? Well, here we have, with aerobic activity, we always have talked about glucose being the main source of energy. But for low intensity activities, we really do burn a lot of fat. We don't realize how much fat we're actually using in addition to carbohydrate, and especially with in low intensity activity. So even just sitting and not, or just walking around campus, you're actually burning a lot of fat. It's released from the adipose tissue to the muscles, and it's used for moderate activities, and that can be converted to ATP, and it's quite helpful. It's a very efficient use of energy because ATP, the ATP is 108 from one 16 carbon fatty acid. You remember some fatty acids are longer or shorter, but if it were a medium chain or long chain fatty acid, it can produce that much ATP. So it's a very efficient energy source. And then just shows here that protein also can be used for energy, but really only 10 to 15% usually is used for endurance or energy sports because you're trying to use the protein, the fat, and the carbohydrate. The branched chain amino acid is the most efficient amino acid for energy. So that's really what this chapter is about: is where the energy comes from, and how do we, how do we use energy? How do we use ATP, and how do we set up a program? So we didn't mention, but make sure you know what the FIT program, the FIT means. So you're trying to do frequency, intensity, time, and type. So it's not just running, but we need to do a variety of activities, not some aerobic, some power, muscle, and some flexibility. How much time should we spend in each? How intense should we do it? And how often should we do it? So those are also covered in this chapter. 5 times a week for frequency, for aerobic activity, and then 2 times a week for muscular fitness, 2 to 3 times a week for muscular fitness, and 2 to 3 times a week for flexibility. And then how much to do. This tells you for each type of activity how long you should do it, what time, how much time, and how intense. So that's the focus of part 1 of chapter 14. Thank you.